Hello everyone. In this video, the limit of a function in two dimensions is to be discussed. In our previous video, we look at how to find the limit of a function in one dimension and also how to determine whether the limit of a function exists in one dimension. Finding the limit of a function in 2D is quite different from finding the limit of a function in 1D. With 1D, we look at how to find the limit of a function using the left hand limit and the right hand limit. So this tells us that with 1D, we need two ways to determine whether the limit exists or not. But with 2D, we need three or more ways to determine the limit of a function. So here we are going to look at how to find the limit of a function in two dimensions. So first of all, let's take the first example. With the first example, we have f of xy is equal to x squared minus y squared all over x squared plus y squared. So here you can see that with all the three examples, we have x, y approaching 0, 0. So first, you have to look at the finding the limit whilst considering the x-axis and the y-axis, because from the points given, we can see that x and y are both approaching 0, 0. So it means that we have x, y. So on our y-axis, we have x to be equal to 0. So this line is x equals 0. And this axis here is y equals 0. So first, we consider along x-axis, which is on the x-axis, y is equal to 0. Then our limits of the function. So we have y to be equal to 0, right? So from the question, we'll be left with x squared all over x squared, where x is approaching 0. So with this, we have x to be equal to 1. So this is our first pathway in finding the limit. Like I said, in 2D, we consider three paths. So this is our first pathway. Now our second pathway is along y-axis, which is x to be equal to 0. So we find the limit of the function. So when we consider x to be equal to 0, we have minus y squared over y squared, which is minus 1. Now we can see that the first pathway is equal to the second pathway. But like I said, we can't just base on two pathways to say that, oh, one is a limit. And here you can see that clearly the first pathway is giving us 1 and the second pathway is giving us minus 1. 1 is not equal to minus 1. So you can say that the limit of the function does not exist as 0, 0. So the limit of the function x of xy does not exist at 0, 0. So this for the first example. With the second example, we are going to look at f of xy is equal to x all over x squared plus y squared. So we have f of xy to be equal to x over x plus y squared. So let's look for our first pathway. So with our first path, we have along the x-axis, which is y equals 0. So we'll be left with x over x squared, where x is approaching 0. So we have this. So we have 1 over x. So here With y to be equal to 0, we have 1 over x, where x is approaching 0. So when you put 0 into the function, you will get 1 over 0, which is undefined. So clearly this tells you that the limit does not exist. So limit does not exist. Now let's go to our third example. With our third example, we have 2x squared y all over x squared plus y squared. So we look at our first pathway along x to be equal to 0, along x axis, which is y to be equal to 0. If y is 0, we'll be left with 0 over x squared plus 0, which is given as 0. So with our first pathway, we had our limit to be equal to 0. Now let's move to our second pathway. We have along y axis, which is x to be equal to 0. If x is equal to 0, we'll be left with 0 over 0 y squared, which is 0. So here, with our first pathway and second pathway, we can see that for both pathways, the limit is 0. But like I said, for limit in 2D, we can't just use just two pathways. So we have to confirm the limit with a third pathway. So since x and y are approaching 0, then we can choose y to be equal to x to be our third pathway. So with y to be equal to x, our function becomes 2x cubed all over x squared plus x squared, which is 2x cubed over 2x squared. So 2 cancels 2 here, half x. So x is equal to 0. So here, from our third pathway, we had our limit to be equal to 0. So we can conclude that the limits of the function exists and it is 0. So with this video, we've been able to know how to find the limit of a function in 2 dimensions, and also how to determine whether the limit of a function in 2 dimensions exists or not. In our next video, we are going to look at the partial derivatives of a function.